Okay, 7-1 basic probability. Probability is really the study of chance. And so that's what we're dealing with. Now we can think about two different types of situations. We can talk about experiments where you're actually flipping coins or rolling a die or actually physically doing something in order to test a situation or event, such as tossing one coin. And if we toss one coin, the outcome could be heads or tails. If we toss one coin but we do it twice, then we could get heads both times, heads then tails, tails then heads. Lastly, tails and tails. That would be all of the outcomes. Rolling a die, we could get 1 through 6. These are called the sample space. When you write out all the possible outcomes, you're dealing with what's called the sample space. Now, you're going to have to get used to understanding and writing out what the sample space is. Because in all of these situations where you're trying to find probability, sample space is very important, and many of you don't like to do that, but you need to. Example 1 talks about rolling two different dice, and then they look at the sample space that they have listed on page 427 and 429. Let me flip in the book and show you what those look like, because it's a lot easier than me writing it all out. So there's the sample space. You can see, why does it sound, okay, never mind. You can see in the sample space you can roll two ones, you can roll a 2 and a 1, or a 1 and a 2, all the way up to 6 and a 6. So this would be the sample space for rolling two dice. Now, we're going to get into different questions about, well, what about the sum of the dice? What about the product of the dice? What about the difference of the absolute value of the difference of the dice? That would be a different sample space based on these numbers, and I'll show you how to do that. But if you're just asking me about things like, well, did you roll a pair of sevens, or did you roll doubles, or did you, something to that effect, you'll need to be able to look at all of the options here. And yes, there are 36 of them. Well, an event, which I've used that term a few minutes ago, is a subset of the sample space. It could be the entire sample space, but and we'll talk about that case in a little bit. But most of the time, it's just a smaller group. So we could talk about getting doubles, or we could talk about rolling the sum of 10, or rolling the product of less than or equal to 3, or flipping a coin and getting heads twice in a row. Something to that effect. Some smaller group of the entire sample space. It's not going to be that hard for you to figure out how to find the probabilities of different events. So the probability, that's what the capital P stands for, is probability, of an event is equal to the number of successes divided by the number of possibilities. That's not something that's going to be new to you. I'm sure all of you will be fine with that. The probability that if I roll two heads in a row, well, I got to know the sample space. So if I write it out, head, 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 tail, tail, head, tail, tail, how many of the 4 options have both heads? Well, there's only one of them, so it's a 1 in 4 probability of that happening. Now, as you noticed, I talked about the word probability. Well, there's two different things we could be speaking of: relative frequency and probability. Now, relative frequency comes from an experiment, whereas probability comes from the sample space. In the last example I did, you saw that I wrote out the sample space, counted how many were in the event that I was interested in, and I called that the probability. Well, relative frequency would be, hey, let's say we flip the coin, and we're going to do it pairs at a time, but we'll do it 5,000 times. How many times will we get? So we could count out of 5,000 times that we flipped a coin twice, how many of those times came up heads, heads? And the higher the number gets, the closer to 25% you would be getting. Now, is it possible that I could come up with 32%? Sure it is, but not likely, especially if I'm doing a larger number of trials. Now, if I'm only flipping the coin 10 different groups of 2, well, then I could possibly get a different relative frequency than the probability. But as I increase the number of trials, it will get more and more likely to be like the probability. Now, if you look at example 4, they talk about having 3 kids. And obviously, we're not going to have an experiment where we take different couples and assign them to have 3 kids. You know, you have 3 kids, and you have 3 kids, and you have 3 kids. It doesn't work that way. So we want to write out the sample space, right? We could have 3 boys in a row, boy, boy, girl. You notice that I'm using a particular method to my madness. So I started out with all of one, and then I inserted 1 and I moved its place. And then I will start with all girls and do the same type of thing, moving that 1 option until I get through all the choices. So there are 8 choices in the sample space of having 3 kids. And what is the probability that you get exactly 1 boy? Well, 3 out of those 8 possibilities have only 1 boy. And that's how we get the probability, looking at the sample space. Events have a probability that's somewhere between 0 and 1, which could include the ends. Now, how could that happen? What does it mean if the probability of the event is 0? That means that it's impossible for the event to occur. Right? The probability of rolling the sum of 13 on a pair of number dice. That's not going to happen. 12 is the highest. Or if I said, what's the probability of rolling a number that's between 2 and 12, including 2 and 12? Well, that is guaranteed because, so that's 100% going to happen because those are the options from 2 to 12. This says if the event E is the entire sample space, that means every event possible, then the probability is guaranteed. It's automatically 100%. If the event E is never going to happen because it's an empty event, this is the symbol that we use for what's called the empty set or the null set. You might have heard those terms. That means no possible event. And if there's no possible event, then the probability is going to be 0. Never going to happen. Okay, and that's section 7.1 notes.